Okay, testing, testing. Woohoo! Here we are. Alrighty. So let me get a couple things straight. Okay. Hello. How's everyone doing? Am I centered? Yes, I am kind of centered. Hello. How's everyone doing? It's been a while now. It's been a couple of weeks. Last week, what happened last week? Did we stream last week? I think we did a short thing on Wednesday, didn't we? I forget. I don't know. Egemen, Via. Hello, welcome to the channel. How are you doing? Kartik, Mikael, Koshik. Good to see everyone. How are you doing? Hola, hola, hola. What is with this crazy hair today? Oh, should I do my live stream like this? Probably not, right? Not for any particular reason, but then when people watch videos, then uh, short hair, and then like crazy hair like this would not be great. Although I kind of like it though. Huh? How does this look? All right. Okay, so what are we doing today? Well, what are we doing today? That's a very good question. Let me pull up my notes. Well, well, first of all, let's start from the beginning, right, Kartik Mohawk? Let's start from the beginning. Hi, welcome. My name is Jose Luis, is written over there, and I run this thing called Parametric Camp. If you're new to this channel, we do live streams roughly every week, not always, but roughly every week. And what we do is we go live, and then we sit down and we record tutorials here live in the company of many of the wonderful people who are right now in the chat and that I get to meet every week, and I get to know each other. Dusko is also very familiar to the channel. Arc Plato, I've been seeing you a lot on the comments in the channel. Very nice words. Thank you for your comments. And so yeah, so we gather here live. We record tutorials together live, and then with also the help from people in the community, they help me edit them out, and then we post them in a bit cleaner, leaner way. Because I do a lot of back and forth, etc. We post cleaner videos that we turn into playlists, and that we hope contribute to help people understand, learn, and become better computational designers. That's what we do. If you already knew us, like Andres, who's also who so comes here and joins us for the live streams a lot. If you already know us, then welcome. Hi again. And I just want to remind everyone, if you're new, that we have a Discord server where we have conversations offline throughout the week. So it's in the description of this video. And we also have a Google Calendar that you can subscribe if you want to know when we go live. We also post stories on our Instagram channel when we go live, so you can follow us. You can get to know what's going on in through a lot of different channels. And we are right now in the middle of recording this new playlist that I'm calling Advanced Development in Grasshopper. And what I'm hoping to do is to teach you how to write code inside of Grasshopper, how to create your own components, and we're building up examples incrementally. So that we will end up building our own plugin, which we're calling it Parametric Camp plugin. Very original name, right? But hopefully it will happen like in a few videos. All right. Arasto, good morning. How are you doing? Arasto is one of the fellow parametric campers who is helping me a lot with editing the videos and making them nice, clean, and elegant for all of you, without all my messy, the back and forth, blah, 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 etc., etc. By the way, Arasto, I think we are reaching soon. We're going to be reaching the point where I'm going to be talking about, where I'm going to be showing your plugin in one of the videos. It's going to be 4.12. Yes, we're going to be doing Remo Sharp. So you may want to be around for that, but that's probably going to happen in a couple of weeks, I think. We're not I still need to record a few videos before that. Jarudi, hello, welcome. Now, also, I want to remind everyone of something very important. Okay, Acadia, the conference for the Association of Computer-Aided Design in Architecture. The conference is happening very soon. I know many of you were already familiar with the workshops, which just happened like 2 weekends ago. But the conference registration just opened this week. So if you want to register, the conference will be the first weekend of November. So, sorry, the first week from the 3rd to the 6th. No, it's actually a weekend. It is a weekend, yes. And it will happen the first weekend of November. And registration is free for students. Can I say this again? If you are a student, you can register for the conference for free. So why not? Literally, if you're interested in the things that we do here, this is a really, really good opportunity to check out what's going on in the world of computational design and what are researchers around the world doing. And also, if you're interested in research, in academia, in teaching, all those things, it's really helpful to come to these events and check out what they are, who is there, the way they present their research. Yeah, I think it's a really, really good thing. And Acadia is arguably one of the leading conferences in the topic of computational design applied to the built environment. So if you are in the architecture, landscape, urbanism way of things, and you like computation, this is definitely a good venue. So let me say this again. Student registration is free this year as it was last year. So if you're a student, go ahead and register and come check out the presentations, paper presentations, the keynotes. I'm going to be there also all around the event. So it will be a nice time to hang out. I actually saw many of you already at the online social platform that we had for the workshops. I was able to catch up with many people. It was great. And the conference is going to be fully online. Yeah, I forgot to mention that. It's fully online. So you don't have to travel anywhere, no expenses. It's no COVID. It's great. Okay. So Acadia 2021 student registration free. Go ahead and do it now before we run out of tickets. Okay. Which I don't even know why I said that, because I don't think we're going to run out of tickets. I don't think we have a limit for tickets. But anyway, okay. All right. So what are we doing today? Today we're doing a double live stream, and today's going to be cool. What are we doing today? We're doing simulation in Grasshopper. Yep. Yeah. We're going to write components that are going to make things move around and bounce and simulate. Are you familiar with Kangaroo and how it's a dynamic relaxation, or like basically a physics engine for Grasshopper? So we're going to be doing very similar things to Kangaroo. We're going to be working with, I'm going to show you how to make examples with particle systems, with things that move around. And with that, I would like to illustrate the idea that you can do continuous execution in Grasshopper. It's not what Grasshopper is designed for, but if you know where to write the code and how to handle it, you can mimic continuous execution in Grasshopper. Okay? Hey, Barbara, how are you doing? Good to see you. And Sachin has a very good question. Sachin is asking, that's not what I wanted to bring up. I can totally do that. Yes, Arasto. So Sachin is asking, what is a student Acadia membership add-on? That's a really good question. So Acadia is both an organization. Let me rephrase that. Acadia is mainly a non-profit organization whose mission is to promote the culture of computational design in the built environment. This is what we do. We have several programs. We do outreach to communities. We have a lot of things that we do, and our main activity is organizing a large conference every year with paper presentations, publications, proceedings, keynotes, etc. So Acadia is mainly the non-profit organization based in the US, but it's also the name that we use for the conference, the Acadia 2021 conference, okay? Even though the organization is the one that organizes the conference. Now, every year with registration, this was how it used to work, with full registration came membership of the organization. And membership means that if you register for the conference, then the year after that conference, you are a full member of the organization and you get some perks. Like, for example, you get access to the internal website. You can post things you can post your work and your projects on the website. And also you get to vote for who will be on the board of directors for that year, the next year, etc. We have elections every year. We have elections every year, yes. So you get to decide who is going to be running Acadia. Now, that used to be the case for paid memberships in the history of Acadia, but because student registration is sponsored by Autodesk, free student registration does not come with membership. So if you're a student and you want to, on top of coming to the conference, you want to become a member of the organization and get the perks that you get by being a member, then you can purchase an add-on for $50, which grants you membership throughout the year after the conference. Okay. And so that's it. And the link to the registration, I'm going to post it on the chat right now. There you go. And hey, Sebastian, what's up? How are you doing? And yes. All right. Was that clear, Sachin? So membership is for becoming part of the organization, and then getting to publish your projects on the website, getting to vote. So for example, I am a member of the board of directors, and I was elected as such 2 years ago. And actually, in order to be elected, in order to be eligible for election, you have to also be a member. And then whereas student registration, the free student registration only gives you access to the conference, no membership. Okay? Beautiful. Now, should we get back to work? All right. So, what are we doing? Oh, I totally lost it. What were we doing today? Yes, simulation. Well, the first thing we're going to do is we need to talk. So the first video is going to be persistent data. Wait. What is my rhino here? Okay. Any questions? I need to set up a couple of things. Any questions before we start? Any other? So 21, 9. What is it today? 29? It is 29. Yeah. Okay. And now I'm going to, yes. So the next video is going to be persistent data. So what are we going to do? I'm going to record a video. What was the last video? The last video was, in the last video we were talking about, we did error handling, and I made this video called Understanding Script Instances. And then we opened this, and then I started unpacking this and this and this, right? And so what I would like to focus on today is this area here, custom additional code. This is going to be for, I'm going to talk about writing functions there. Yes, I actually have it on my notes already. So we're going to write reusable functions there, and we're going to add a class. So for example, no, continue. Actually, that's not. So the first one is going to be extending the custom additional code. That's going to be one video. The second video is going to be persistent data. that's where I'm going to talk about things that move around, etc., etc. Yes. That's what I'm going to talk about. Yes, exactly. So which example am I going to do? I don't need to do a complicated example here because that will come on the next that will come on the next. So we're going to have, in this video, I don't need an introduction. How am I doing battery-wise? I don't need an introduction. So how am I going to start this? I'm going to start by double clicking here and explaining how using, okay. I'm going to start by showing this and showing how in the previous video we're talking about all these members and the utility functions, etc. There is the using, which I will talk about in a few, but I would like to focus here today on the custom additional code. I need a good name for this video. I'm going to ask you for a name for this video. Yeah. What about extending script functionality? That sounds like a terrible name. Yeah, I'm not sure about that. Okay, I'll think about it. So I'm going to, did I have too much coffee this morning? I barely had any coffee. Why am I so why am I so out of control? Okay. Okay, let me think through this. Martin, 60 hours a day. What can I say? Sorry. Well, maybe not 60 hours, but 60 days. You can maybe, I don't know. I mean, what do you do on the weekends? You hang out with people? Seriously, that's so overrated, right? Okay, let me get back on track. So I'm going to start the video. I'm going to refer to the previous video where we talked about the members that were part of the script instance. What I want and what I would like to say today is that I would like to focus on this other part, which is the custom additional code. And we do that because this is the part where we can extend, this is going to be the core, we can extend the functionality of the script instance. So instead of just writing code, we can actually write reusable stuff in this part. So, and that's going to be functions and that's going to be classes. Then I'm going to do the example of the function. I'm going to write a function and I'm going to write a function and then I'm also going to write a class. And then I'm going to show how the classes don't really, cannot be exchanged between the script instances. And I will, but I will say that we will see ways of why that's the case and that. Okay, I think I have it. I think I have it. All right. Woohoo! I'm going to change this to A and B, for example. Okay, and B is going to. And then I'm going to create a vector here. Actually, no, why don't I do X and Y? Yeah, X, Y, and Z. And then this is going to be a double. and double. No. And then this is going to be okay, and here, and okay, and then a panel here with the vector, and another panel with the length of the vector. And I'm going to keep it on the side. Okay, I think I'm ready to start. Let's do this. Hi, this is Jose Luis here at Parametric Camp, and welcome to another video in this series, Advanced Development in Grasshopper. In this video, I would like to continue with breaking down some of the complexities that are part of the C# script component. And in the previous videos, we saw how if we extend all these regions that are by default hidden, then we can see the internal utility functions, so the methods that are available, like printing or reflecting on objects. And we can also see the members that C# script components give us to access things in the ecosystem of Rhino and Grasshopper. Like, for example, instances to the Rhino document, the Grasshopper document, and the particular component that is running this script. We've seen that in previous videos. We also know that we can write code here, and that we have been doing throughout the series. But I would like to focus today on a particular area that we have not yet seen, and that's not going to be the top one with the using and how to import libraries. We will see that in a couple videos down the road, but I'd like to focus today on this area here, the custom additional code, because this area is an area where we can write additional code that we can use to extend the functionality of this particular component. If you are familiar with C#, we already broke down how C# script components are basically instances of a class that inherits from some Grasshopper class that is available out there and has a lot of functionality, but we basically subclass it. And that's why it has its own methods, its own members, and this one particular function that Grasshopper knows it has to execute for each component. But at the end of the day, this is just a class. And because it is a class, we can extend the members, the methods, and a lot of functionality of this class by just adding more stuff beyond the simple run script function that we use as default for writing code. And that extension happens here in this area. This is an area where I can actually write additional code, all right? And we typically use this area for a few things that we can add to extend the functionality of a script component. One very simple way of extending that functionality is by adding additional methods, so additional functions that help us do operations that perhaps we repeat over and over again. So for example, I have here right now, I have a component where I put XYZ as double inputs, and these are numbers, and I hope to use this component to create a vector out of these XYZ coordinates and to output the length of this vector. There's actually a component just like this in vanilla Grasshopper. So we already know that, for example, I can declare a variable here, vector3d, and I can call it lowercase v, or I can call it vec, and that's going to be a new instance of a vector object with coordinates x, y, and z. Okay? And I can output, so I typically, I do algorithm, and and I do output, so I can output that throughout the component, and you can see that now I have my vector out here as an output. And we already know as well that for length, the vector class has a property that is called length that I could use to just calculate this length right away, okay? But let's imagine that we didn't have this for whatever reason. Let's imagine that we needed to make our own calculations for the length of a vector. So how would that work? Well, if I have the vector, so we know that we can do an operation where we can say the length of the vector is going to be the square root of vector dot x, so the x coordinate squared, right, plus the y coordinate squared. So that's going to be vec.y. So we're doing Pythagoras here, and we have a bunch of videos in the channel that explain why this is the case. Okay, sorry, this is not a plus, this is a multiplication. Okay, so the length of this vector is the square root of each one of its components squared. Now, if this is, imagine that this is a very common operation that we want to do. We probably want to abstract this into a function. So where would I write that function? That function, I cannot write it right here because in C# you cannot write functions inside other functions. However, in the custom additional code is this area that I can use to write my own functions that I could reuse over and over again. So what I could do here is I could say, I'm going to create a function that returns a double because I want to return the length, and I'm going to call this vector length, all right? And this function is going to take one argument, which is going to be one element called v, for example, that is going to be the vector, all right? And then what I can do is I can take this and I can just paste it here, sorry. And then this should be v and v and v and v and v, now that it lives inside of here. And the return is going to be that value. What I can do with that is that I can now say, well, I can now say that the output length is going to be equal to the result of this function that I just created, vector length, on the vector that I created up here. And if I run this code, you can see that nothing changes because the result is the exact same one. What's beautiful about this is that vector length is an operation that is available in Rhinocom or whatever, but if I didn't have this operation, if I wanted to create my own function that I needed to reuse over and over again, then I have just written here a reusable function that can be used throughout my maybe very complex algorithm here in my C# script component, okay? Also, technically, what we know is that because all of this is a class, because this whole thing is a class, what we just did is that we added our own custom method to the class so that it could be used by other functions inside of this class. All right, so that is technically what we just did. So we can add functions to the custom additional code in case we need to reuse them over and over again. But there's another thing that we can add. All right, I felt I was going to start going downhill, so I needed to take a quick break. How's everyone doing? Yoo-hoo! Okie dokie. So I'm going to be talking about classes now. And I want to make an example of a person class. So I'm just going to leave this here. And I'm going to create another C# component. And I'm going to call this string. And I'm going to call this name. And this is going to be H. And this is going to be P. Another thing that I can add into my script instance classes and here in the additional code is that I can actually write my own classes that I could reuse throughout the life of a script instance. So remember, C# is a object-oriented programming language, and very often when we work with a lot of data and with complexity, it's just easy and nice to encapsulate things in classes and in objects because it makes managing things much easier. So, for example, I can do that by creating classes that live inside the script instance class. So for example, I created a new script component that is taking a string called name and is taking an integer called age. And what I'm going to do here, and I'm going to output a class of the type person. So for example, what I'm going to do here is I'm going to create a class that I'm going to call person. All right. And I'm going to give it a couple of properties. So it's going to have a public property called name, and I'm going to have a public property integer called the age, and then the constructor is going to take those as inputs. So string name, string age, and then it's going to save them as part of the properties. Okay. And it may have, for example, it can have a function called say hi. So for example, it can return a string, say hi, and then when we call this, then it returns a string that is something like, hello, my name is name, sorry, this.name, and for example, and I am this.age years old, for example. So that could be a function. All right, and we could also override, for example, the toString method to just return this.name plus this.age. Okay, for example. So this is a class that I just created that represents a very simple thing, just a person with a name and an age. Okay, what that means is that given now these inputs, I can, in my main code, I can instantiate a new instance of a variable of the type person. So for example, that's going to be Jose Luis, all right, which is going to be a new person, which I think I need to make this public. Yes, a new person with a name and the age, all right, and I can output that over my output here. And if I run this, you can see that, well, let me cancel this out for a second. Let me cancel this out for a second, and then we will fix that. And then here, I'm going to write here Jose Luis, and I'm going to write here my age, which is 100 years old. All right. So I have this, and I have an error. Does not contain that takes 2 arguments. Oh yeah, because I need to make this public as well, and I need to make all of these public so that they are accessible. And then I run this, and then, oh my God. Oh, so yeah, so I have a typo here. This should be an integer. Okay, beautiful. And then if I put this in here, so you can see that the default is that I have a person object that is coming out, but the printout of that is this weird thing, which is this is a person class that is living inside of a script instance class. That's why I wanted to override the string method. So let's see, but exactly. So if we override the string method, then Grasshopper and C# will know that in order to turn this object into a string, they need to change that, they need to use this default method, okay? If you want to learn more about how to write classes, we have a video also on my Learning C# playlist. And if you want to learn more specifically about the toString method, I believe I also have a video about that. So those videos should be popping as cards here on the corner, or they should probably be in the description of this video at some point, okay? And so yes, so now Jose Luis is 100 years old, we can change his name, etc. Okay, so If for some reason I was writing a component that was using lots and lots of instances of persons, then this would make sense. All right, this would be a super, super helpful thing to do. However, the only drawback is that, let's say that I wanted to create now a new C# script component that is going to take a person. All right, let me show you the problem here. Let me say I'm going to save this. Okay, this is going to work, and then this is going to be of the type system object because Grasshopper doesn't have a person class because I just created this custom. So I'm going to take a generic object, and then I will try to cast it, and then the outputs are going to be the name and the age. So let's imagine that I wanted to write some code that would take a person class and then a person object, and then would spit out the name and the age of that object. Okay, so we might be tempted to think that, oh well, since I have the class person in the first component, I can just copy this and then I can now paste it here, and it's the same class, right? So now what I can do is I can say I can declare a person object called person, and that's going to be casting the input P into a person class. And then for name, I'm going to take person.name, and then for the age output, I'm going to take person.age. All right. So I would be inclined to believe that this could work, and this actually kind of makes sense. But if I do that, turns out that this doesn't work. And the reason why this doesn't work is that Grasshopper cannot convert this person object, the one that is coming from my previous component, to an object of this class. It just cannot. This conversion is not valid. But wait, how does that make sense? I mean, it's the exact same code. I just copy pasted it from the other component. So why can they not change? Why can they not convert from one to the other? Well, it turns out that because this class was defined in two different components, even though the code and the text and all the details are the exact same thing, because they were defined in two separate instances of classes, then internally they have different signatures, they have different memory addresses, and to the computer's eyes, they are different because they were created in different places and they cannot be matched together. This might be counterintuitive for us because, again, the text, the written code is the exact same thing, but because they were created in separate places and with separate codes, and they have different memory allocations and different signatures, to the computer, they just look different. So, so what we need to do then is that in order to do this, there are ways to go around this. And we will see in future videos that something that we can do is we can declare this class in a separate file. So we can create a class that we can create a file that contains only this class, and we can load that file in different Grasshopper components. And as we do that, we would be able then to use the same code that has been generated in the same place into different components. I'm going to verify what Arasto is saying. Nope. Arasto, this doesn't work. I'm still getting the same problem. Doesn't that work with internal classes? No. Object reference to syntax 59. Yeah, no, because this conversion cannot happen. And because it cannot happen, person is null. The only thing with as, when you do conversions and casting, is that it doesn't throw errors. If the conversion doesn't work, then the return is a null, as opposed to an error thrown. So this becomes a null, but at this point when you're trying to access this, this is null. So I am not sure how you were able to do this, Arasto. But I'm going to give you, if you have ideas, just put them on the chat, because as far as my understanding goes, this is just not possible unless you turn the class, you put the class in a DLL, and then you load it as an external reference. Let me save this file before I lose it. Okay, and that's going to be ending script functionality. All right. Well, if you figure it out, then we can just record a clip and insert that clip in there. Let me add cards to classes and do. All right. What else do we got? I also want to talk about variables. Okay, I want to talk about variables. The last thing that I would like to talk about is another thing that we can add in the custom code section, which is that we can actually add variables here. So, for example, just like I created a method, I could have here a variable that is called, for example, I don't know, let me call this Boolean, I don't know, is Jose, I don't know, have you had coffee, for example, and we can turn this to true, right? And then if we do that, then it turns out that this variable will be available not just to the functions that live here, but it will also be available here in the main code. So for example, if I close this and I write here a new variable, caffeinated, okay, and then I spit this out here and as a panel, then something that I can do is I can add to the outputs here, caffeinated, I can add here the value of this variable that has been hard-coded here in the code. So if I write this, now this is true, and if I change this, so now this is false. Why is this interesting? Well, that's actually something that I would like to further unpack, because this, being able to declare variables outside of the main run script function, is actually extremely helpful for doing other things, such as, for example, having persistent data that lives in the Grasshopper component and it doesn't change or it doesn't get removed whenever we re-execute the component. And that is going to be super interesting for things such as creating dynamic simulations or giving the impression that the Grasshopper script has a life cycle of its own. Okay, but that I'm actually going to focus on the next video. So join me on the next video as I talk specifically about the idea of using variables here for having persistent data and therefore creating continuous execution of sorts inside of Grasshopper. Okay, so I'm going to cover that on the next video. In the meantime, if you like this video, maybe like the video, subscribe to the channel, say hi, join Discord, etc. etc. Okay, thanks a lot. See you on the next video. Bye. Arasto, did you figure this out? Okay, I'm going to take 1 minute bio break. I'll be right back. Okay, let me know if you figured it out because we can record that clip and insert that video. Okay, I'll be right back. All right, not yet. Okay, I am not a person to discourage people from doing things, but it is my belief that this problem can just not. It's just is part of how Grasshopper works. So maybe you were doing this, but you were actually bringing in those classes from an external file, which is the solution to that problem, and which I will cover in further videos down the road. Okay. Batteries. Can you let me know if the battery goes? This probably still has like an extra 30 minutes before it goes. All right. So what is the next video? What is the next video? And the next video is going to be extending continuous execution in Grasshopper. And that is going to be, what is that going to be? It's going to be, that's going to be, so what am I going to do? So first I want to show, I'm going to write the examples first, okay? And what I would like to do is, executions. So we take X and then we just poke it, and then we have here a public iterations, and that's equal to, and then iteration plus plus, and then executions, and that's going to be ITA. And then we just have this here, and then the more I do this, the more iterations we have. Oh, what? Exactly. All right, so that's one thing. And then I may want to add a boolean to reset, and then we can just say button, and then if reset is true, then iteration is going to be 0. Okay, so we can do that. Reset. Okay, and then and then we reset. So So that's going to be one. The next thing that we can do is, and I can probably put a trigger on this so that we can see how this can actually execute on its own. So for example, we can do this. So that's something we can do as well. And then okay, and then what I'm going to do is I'm going to say, I'm going to create a point here. I'm going to create a point, and then I'm going to create a point. I'm going to bring the point inside. I'm thinking through the examples that I'm going to make for the tutorial. I'm going to take this point, and then after I do that, I'm going to write something that takes the point, takes a direction vector, and has a reset flag as well. And then the point vector, and this is going to be x, unit x, for example this, and then it's going to have a button. So, and then here the full code would be if r, which needs to be a boolean, if reset, then so I have to have here a point3d location, and then if r is location equals, and that's we're going to initial, for example, to point 3D unset, for example. If then what we do is location is going to be equal to p, and then location plus equals v, and then the result a is location. Okay, and then if I do that, then what should happen is that I should be able to trigger this, and it's a null point, but if I reset, then this should, okay, and then I can reset that, and then what I can also do is I can have like some kind of guiding vector of some kind, and between 2 points I am thinking of the examples that I'm doing again, and then I can do a vector between 2 points, and I can draw this vector display, I can draw the vector here and here, but I can also draw the vector on here. That could be cool. And then I can use this vector, you see? Whoa, this is kind of cool. Oh, no, 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 no. There you go. Yoo-hoo. Okay, that's kind of cool. Okay. All right, so okay, so what do I do with this now? I'm just going to keep this somewhere here. And okay, so I have the examples. Now, how am I going to tell the story? How are we telling the story? Storytelling is very important when you do these things, when you record tutorials or when you teach. The story is we are coming from the previous video where we're talking about extending functionality, and now we're talking about creating variables. But I think the point that I want to make is that variables that we declare outside of the script function, they become thank you, Arasto. I like being absolutely right. It doesn't happen always, but when it happens, it's nice. I might be wrong, Arasto. But I just think when I had to deal with this, I was looking through forums, etc., and even David Rutten was saying that this is just not a possibility. Okay, so I want to make a case that the data is persistent because the component doesn't change when the function gets executed. And then, so how do I start then? Let's say that I wanted, for example, to measure. Let's say, for example, that I wanted to measure maybe I can start with the problem. Maybe I wanted to measure how many times a component has run. Okay, so let's start with that problem, and then we can. Okay. Mm-hmm. Let me get to this. It can work as a trigger, Kartik, you're right. But then it updates automatically, it triggers itself, and then it's a bit more difficult to control than that. Okay, let's start. Hi, this is Jose Luis here at Parametric Camp, and welcome to another video in our series, Advanced Development in Grasshopper. So in the previous video, I discussed how there's this special area, this is a special section on Grasshopper's C# script components called the custom additional code. And I discussed how we can add functions and classes here to extend the functionality of a component, but I also discussed how we can add variables. And that seems a little odd because why would I want to add variables? Basically, I can have whatever data I need, I can have it coming in from the inputs, right? Well, it turns out that what's really interesting about declaring variables in this area, or in C# terms, creating members that are full members of the class that are not declared inside of a function, what I gain with that is that the data and the values that are inside of those variables all of a sudden become persistent. And by becoming persistent, what's really nice is that we break free of the paradigm that regular Grasshopper components have about data being volatile or only existing for a particular solution, for a particular execution. And this has advantages when we want to do things that are a bit more complex than regular cyclic graph computations, such as, for example, creating simulations or giving the impression that we are doing continuous execution inside of Grasshopper. That was a mouthful, but what does that, let's see examples of what I mean with all of this. So for example, let's say we have a C# script component and it has some kind of input, whatever. It's a dummy input. We're not even going to use it. So it's just something that is changing over time, all right? Or it changes with the scrolling of a slider. And this data could be used for this component for whatever calculation. I don't know, calculating half of the value. It doesn't really matter. But what I wanted to do is, on top of whatever calculation this does, which is, for example, going to be, calculating that A has to be equal to AX divided by 2. And actually, in order to do that, I should turn this into a number, which I absolutely forgot, all right? So A is going to be 6 divided by 2, whatever. Just some random calculation. But what's interesting for me is that I want to use this component to also calculate how many times in the life of this component has been executed. So if I'm doing this, if I'm scrolling this, how many times this value has been calculated by this component? Or in other words, again, how many times this component has executed the run script function. Correct? If I wanted to do that, I might be inclined to say, well, let me define first here a variable that I'm going to call iteration, and then I'm going to initialize at 0, and then every time I run the script, I'm just going to increase it by 1 unit. And then here over executions, I'm just going to output that value. If I were to do that, let me plug in a panel here. If I were to do that, right now I get the value of 1, but as you can see, as I keep executing this component, the value of 1 is not changing. And it's not changing because if we remember the rules of variable scoping, the variables have the scope of the block of code in which they were declared. Because int iteration has been declared inside of this function, what is happening is that Grasshopper, every time Grasshopper executes this function, this variable gets created, it gets a value of 0, it gets increased by 1, and it gets output. But then, as soon as we hit this curly bracket, this variable expires, this variable ceases to exist, and therefore its value doesn't carry on to the next execution on the next time we execute this component. You see what the problem is, all right? But this is very simple. It's just because, again, variables only have a lifespan of the block that they are declared in. What's the solution then? Well, the only thing that I need to do is I need to declare that variable somewhere where it will not expire when I execute my function. And that somewhere, as I was saying before, turns out to be in the parent scope to the function, which happens to be the root scope for this class. So when the variable is declared here, all right, the variable, it becomes persistent. It exists throughout the life of the component, and every time the component executes the run script, it doesn't create a new variable. It just reuses whatever value it had. So for example, let me now press play. I have moved this here, and now let's check what's going on. As soon as I move the component, you can see how the count of how many iterations I have executed, it just keeps going up. Every time I give this component a new value, anytime I change any of the inputs, even if this was not being used whatsoever, okay? Even if that was not the case, even if there was no such calculation, I would still be executing this component over and over again and getting all these iterations. You may have seen that something happened when I changed the code and I executed this number went back to 0. That is because changing the code actually does change the whole thing, because Grasshopper internally needs to recompile this C# script component, and therefore this gets reset to 0. Everything gets created again. But that only happens if I actually change the code. If I don't change the code, and if I just keep this here forever, then this number is going to keep increasing forever. And again, right now I'm using this input just as a way to trigger this component to execute again, even though the actual value, I'm not using it at all. And actually, in that same spirit, let's see what happens here. Let's see, I remove this because now there's no input. This gets executed again. But if you remember, there's this other component called the trigger. And the trigger is a component that is very popularly used. You can drop it, you can link it to a component. And the trigger is a component that does this effect called ticking. And ticking is, in computer programming, is something that is referred to activating or triggering something without no effect or without really caring about the data that is triggering that event. Okay, so if I do that and I press play here, you can see how the trigger actually does tick this component and it forces it to execute again. And if I set a timer, so for example every 100 milliseconds, you can see that this component is ticking and is forcing this component to run script again, and therefore this component keeps increasing. For example, let's say that I wanted to now, for example, let's say I'm going to declare here a value that is going to start at 2, okay? And then every iteration value is going to be equal to whatever it was times 1.2, for example. And I'm going to declare another output here that is going to be B, for example, and then B is going to be equal to that value. Okay, if I do this, now you can see that B has the value of 2.4, but if I now execute this, you can see how this value is going to start increasing exponentially. Not exponentially, but it's going to start increasing until it reaches like a very large value. You see, because this data is persistent. Okay, shall we take a look at a cool example of how this can actually be helpful for doing simulations? Should we write something where we can move a point dynamically in three-dimensional space? Well, before we do that, I actually forgot that what I wanted to do is I wanted to figure out a way, because right now this keeps increasing forever and ever. And if I did not have the capacity to actually change the code, I would not be able to reset any of these values. Is there any way that I can implement without changing the code a way to reset any of this? I think there is. So let's say that I'm going to include a new input called R, and which is going to be of the type Boolean. Okay, if that is the case, I'm going to put a button here, and then I'm going to double click and I'm going to use this flag, this input, to reset all the values. So the only thing that I'm going to need to add is if R is true, or we know that we can shortcut this, if R is true, then what we can do is we can say whatever IT was before, I don't care anymore, I'm going to force it again to become 0. And whatever the value of val was before, I also don't care, I'm going to initialize it again to the value of 2, right? So let's take a look. I'm going to use my dummy input to manually force some updates here without the trigger, okay? I can also use the trigger, that's perfectly fine, but then if I press the button, you can see that I just reset everything. And it's interesting because I press once and it gets reset, but as I release the button, that triggers another update. So now this component has been executed twice. You see how interesting that is? Because this input goes from true to false, and that's 2 executions of this input. So I could have this running infinitely, and I can have now a button that I can use to reset these operations as we go. Okay, beautiful. I think it's time now to see an example of how can we apply this to moving geometry or simulating geometry. Hmm. Hmm. So for example, I have created this scaffolding component, which is, I have created a point in Rhino. I have brought this point with a parameter component here. So I have the point now inside of Grasshopper. I have a unit vector in the x direction. We will change that soon. And I have a button just to reset the component. And the component has those inputs as points, as vectors, and as a Boolean. And then what I would like to do is I would like to write a simple dynamic simulation where every iteration of the calculation, this point is going to be displaced by this vector. Okay? And just to do a vector display, I'm going to display the direction of the vector. So that's this one. And this is going to be the point. So I will also want to show the point being moved by this vector in this direction. Okay. So what I'm going to do, you see how my inputs are a point P, a vector V, and the reset flag. So what I would like to do is I would like to write some code that takes this point, and every time we update the component, it moves the point along the vector direction. So the first thing that I need to do is I need to first create a persistent point, a point that I'm going to use to store all the values that are changing and that is not going to be reset every iteration. I do that by creating it here outside of the run script function in the custom additional code part. So I can say, for example, point 3D, I'm going to call this current location, like a really long name, okay? And I'm going to, because point 3D is a struct, it needs to be initialized. It cannot be null. That's one of the things, that's one of the properties of structs versus classes. So I have a card. There should be a card popping to struct versus classes somewhere in the description, whatever. And I need to initialize it to something. So point 3D, the class actually comes with a particular version, which is an unset, which is basically a point that has no valid outputs. Okay? And then what I would like to do here is that every time, or I could also, for example, I could initialize it to new point 3D 0, 0, 0. Okay? It doesn't really, well, it does matter, but we're going to see why. Okay? And then what I would like to do is every time I execute my code, what I would like to do is I would like to take the current location, and then whatever it is, I want to update that point and move it by the v vector. So that my moved point is going to be whatever current location was. Okay? If I run this code, you can see that my point is actually now on, my point is right here. Let me highlight it. The point is right here. And if I put a trigger and I start updating this every, for example, 200 milliseconds, you can see that the point is moving every iteration, every time we hit is moving 1 unit in the x direction. You see that? All right. Now, the problem is that, well, there's a couple problems here. I started at 0, 0, not at the point that I wanted. So could I change that? So for example, maybe we could say current location, I want to initialize it to P. But you see what the problem with this is going to be? If I run this, I get an error which says that P doesn't exist in the current context. That is because P is a value that is coming into the component, and because of the rule of scoping, this variable only exists in this block. It doesn't exist here. So that's why starting the point with an unset value so that the component doesn't work unless we do a particular thing, like you see, it's a null point. Unless we do that, it doesn't work. And then how can we fix that? So because we have the reset flag, what we can do is we can say, I'm going to say if reset equals true, then what I'm going to make sure is that I reset everything. So current location is going to be equal to the initial point. All right. And then after that, I'm going to update it. What's beautiful about this is that now this code is not running because, again, by default, the point is set to be this point that is not valid called the point unset. But as soon as I press reset, then we forcefully turn current location, we initialize it to the value of p, and then from there on, we can actually now start working with that vector and simulate it. All right? Beautiful. And I can reset, and now we basically have a moving point that we are simulating, right? We are calculating its new position every 200 milliseconds, and we are changing that position by a particular direction vector that in this case is a unit x. But it didn't have to be a unit x. What if the vector was a vector that I was actually controlling dynamically in real time? So I'm going to take those 2 points, 1 point, another point. I'm going to create a vector between those 2 points. I could do this with C#. I'm just doing it manually for the sake of speed. And then I'm going to use this vector. I'm going to plot this vector here. This is the direction vector. And I'm going to use that vector here. Okay? And and what the result of that is going to be that if I reset, you can see that the vector is moving, but I can move the vector. If I change the vector, you can see that I'm dynamically controlling with these 2 points the direction that my point is moving along. And the speed, because if it's a long vector, then it moves very fast. If it's a short vector, then it moves much slower. But can you see, we could probably create video games almost with this stuff, right? And actually, I would like to take some time in the next video to put this idea to practice. So if I put the point on top of itself, then now it's just, I stop the point, you see, because the vector is 0. But I would like to take some time on the next video to make a few examples of this, make a few examples of how can we create components that work with geometry dynamically and with changing states of geometry, which is a technique that is very useful, for example, for simulations. Okay, so if you like this, I think you're very much going to enjoy the next video. It's going to be a hands-on one. So hope to see you in that video. If you like what you saw, maybe like this video, subscribe to the channel, say hi, join Discord, buy me a coffee. However that looks like, I don't know. Anyway, or just say hi. That's also perfectly fine. Thank you very much and see you in the next video. Hands-on examples of dynamic simulation. Bye-bye. All right. Well, that was a lot. I kind of have a headache. 4.6. Continuous execution. How are we doing? Was this fun? Oh. All right. Okay. Oh, I do have a headache. A very nice one. Oh, God. Okay. So, the next example The next video is going to be continuous execution. So I wanted to make simulation components. Thank you, Richard. I wanted to do simulation components, but I don't have the examples done, of course, and I think I don't want to do them live. So I don't want to I guess what I want to say is that I would like to spend some time putting together the code first, so that I have a guide, and then when I record the videos, they are much cleaner. So there's no big difference, Arasto. It's just that using the trigger is an external way of ticking the component, whereas that way that you specify, it's internal. It's code that you hardwire inside the component. But they're basically both the same concept. And you know what? I have a little bit of a headache, so I think I'm going to stop this live stream, this one, and I'm going to go take some medicine and run a couple errands that I need to run, and then I'll be back in the afternoon, and we will spend whatever time we need to prototype the examples, and then if we have a time left, then I will record the video for the simulation components. I want to make one simulation that is going to be a rectangle and a point, and the point is going to be bouncing off the rectangle. That's going to be one thing. Another one that I want to do is I want to draw a pendulum, so that swings and that somehow has friction, that swings over gravity, and that has friction, gravity, whatever, and then it gets simulated. I would like to simulate, like in Kangaroo, having 2 points and having an elastic chain between them. And I would probably want to do a similar one that is just one chain. I will not be covering multi-threading at this point, Richard. Okay. All right, yes. And I'm going to, I have a little bit of a headache right now. So, I'm losing it. We have to do this more often so that I get more training, right? Okay, so I'm going to stop this live stream. Thank you very much, everyone, for being here. I will see whoever is interested in doing simulation components. I will see you in the afternoon, okay? At 2 p.m. my time, Eastern time, which means in 2.5 hours from now, okay? Thank you very much and have a good one. Bye-bye.